Today we are going to be using polynomial division to change a function into something that we graphed yesterday. So yesterday in your homework, you were graphing rational functions that were based on the parent graph 1 over x. And you had multiplication by numbers. You had moving things horizontally and vertically. But now what I'm going to do is give you problems where you're going to figure out what the manipulation of the parent graph is by performing division. So here we go. If I am dividing by x minus 1, then I'm going to put on the left x and minus 1. Then as I get ready to divide, I take the leading term of what I'm dividing, put it in the upper left box, and then I need to figure out what do I multiply x by to make 3x. And you guys say in chat, what do I need to multiply x by to get 3x? Yay, 3. Then I multiply the 3 times negative 1 to get negative 3. And then the next thing that I need to do is figure out what do I add to negative 3 so that I get positive 8.
11.
Very good. And guess what? Division is done. Your division is done when your quotient hits the constant, which is what we hit right at the beginning. And we have inside the boxes an entire 3x plus 8. But what we have is a remainder. Our answer to this division is an entire 3 plus a remainder of 11, and that 11 was not able to be divided by the x minus 1. So we're going to start off with what?
So to get the 3, is that just because you switched the negative 3 into the 3?
This 3 is coming about because I had to figure out what I needed to multiply this x by to get, which would be this x, to get, let's see if I can color code this a bit, in order to get this 3x. And I found that I needed to multiply this x by 3 to get the 3x, and that is literally the entire quotient. So these are actually quick division problems that almost seem like they're so short that you didn't do a whole lot, but you did do a lot in you changed the way the function is presented. So instead of being a linear function divided by another linear function, you know how to graph the parent graph y equals 1 over x. By doing the division and changing the format of the way this is written, what you can look at is this remainder of 11 is actually going to cause the 1 over x graph to be multiplied by 11. So that's the first change. And I failed to actually change it. There we go. Then, once you have 11 over x, You then have the minus 1 to the x and the plus 3 to the function, which is going to cause it to move wrong direction. It'll move right 1 unit and up 3 units. So what we do is we start off with the parent graph, and I'm going to draw the parent graph in blue. And all I need you to draw are these central points of 1, 1, negative 1, negative 1. So I've got this graph right here, and their asymptotes are right there in the middle. Now, when I multiply the function by 11, I'm actually going a little bit off the map. I take the y value 1, multiply it by 11, and that's going to actually move it up here, because this is 10 right here, so I've got to go up 1 more unit to 11. When I take this negative 1y value and I multiply it by 11, it also goes 1 unit farther. Did I draw that in the right place? Yes. Okay. And that's how this graph gets stretched. And I don't expect you to draw the most perfect graph, just acknowledge the stretching. It's still asymptotes. It still has the exact same asymptotes as before. Now, after that is done, we can then move this graph right 1, up 3. So if I take this particular point down here at negative 11, and I move it right 1, up 3, 1, 2, 3. Now, this one goes a bit more off grid, but I can do some symmetry to help with it, but I'll go ahead and say what point that is. If I move, and now I forgot, up 3, right 1. If I move up 3, I'm up at 14, and right 1 takes me to 2. So I'm just going to say that that is the point 14, comma 2. Okay. But very importantly, this is telling me where my asymptotes go. And this is probably the most important thing. So the center of these asymptotes moves right 1, up 3. So when I draw my asymptotes, they are going to be along these places. And then from there, you're just going to do your best drawing the basic shape. And understand that it is following those asymptotes. And you can see how that's not fantastically drawn. And for the answers, what I did was I tried to show I put on there a graph that went a little bit further out and showed you the blue starts the 1 over x parent graph, the green is the multiplication by 11, and then the red is the final graph of taking that green graph and moving it. And then I have over here just the answer part of what you can see on your 10 by 10 grid. And the multiplication by 11 makes this one a little bit awkward, which is why I put this one in classwork instead of homework. But let's take a look at, doesn't work well? What do you mean doesn't work well?
Color blindness.
Oh, I'm sorry. I'm sorry. That's frustrating and I can't help you. Okay, let me point out this is the parent graph. And I'll just do the upper right corners. This is the multiplication by 11. And then this one is the final. And I'll color code then again. This is the blue. And then this is the multiplication by 11. And then the movement. But there you go. With the main thing is to get that final graph. And you don't have to draw the entire graphs on the way there, but you can if you want to. Now, let's look at the next example. We're going to do the same thing with division. So see if you can do that. It doesn't need to be accurate as long as we have a point. Yeah, I will tell you the biggest thing I'm looking for is where your asymptotes are located. And also that you're in, let me explain through yesterday's homework. Once you know where your asymptotes are located, you are either you're either in this pair of opposite corners or this pair of opposite corners. And I need you to be correctly in the correct opposite cornered positions of those asymptotes. That's the biggest thing, are the asymptotes being in the correct position and then being in the right quadrants of the four that this cuts it up into. And when you're dealing with the parent graph 1 over x, it's always going to show up in opposite quadrants diagonal to each other. And there's opposite quadrants, and here's opposite quadrants in the other direction. So let's try this division. We're dividing by x plus 2. And the thing being divided is 4x minus 1. The 4x is going to go in that upper left box. I have to figure out what do I multiply x by to get the 4x. And you say, mm-hmm, 4. Then you can complete 4 times 2 gives you 8. And then you need to add to 8 something that will make negative 1. And so what number needs to be added to 8? You got it. And at this point, the division is done. So on your homework, all of your problems where you're graphing are a linear polynomial divided by a linear polynomial, and their division will be this quick, every single one of them. And then the answer to the division is the quotient, which in this case is 4, plus the remainder that did not get divided by the x plus 2. So for this problem, you're technically starting with the 1 over x graph, who has asymptotes right at the very center, and who is in basically quadrants 1 and 3. Yeah. Okay, why did you... My pen is not wanting to work. Here we go. And I'm not drawing fantastically, just kind of getting the idea that it's in those spots. Then, what happens when I multiply by -9? What does that cause very, very importantly to happen? So these two, the parent graph is in quadrants 1 and 3, but when I multiply by the -9, it's going to move to being in the other quadrants 2 and 4. At the same time, it is stretched a little bit. So where you have a y equals +1, multiply that +1 by -9, keep the x coordinate, and you can see where that point got flipped and stretched. And then the other one, y value -1, multiplied by -9, flips and stretches that over to that spot. Now, do you want to see a nifty trick? When I do that multiplication, I'm looking at the results when I plug in x equals 1 and -1. And I could do a t-chart if I wanted and plot some points off of this stretched graph. And I can see that when x is 1, I get -9. And that when x is -1, I get +9. But here's something pretty unique to this particular function. What if I make the x coordinates 9 and -9? What y values come out of those?
-1 and 1.
Yep. And so this happens every time when you take a parent graph and multiply it by a number. So it allows you to get a couple of nice points going without having to really do much with plotting, other than realizing that these kind of swap around. So I can add in some extra points to help with the graph, and then just kind of show that it's attempting to follow asymptotes. And stay in the quadrant. Now, the last thing that I do, let me start again. I have my parent graph, then I stretch it to this new graph, and the last thing is the movement. The movement looks at what number is added or subtracted with x and what number is added or subtracted to the function. So according to those two things, how does my newest graph move? And I'm checking chat. I move left 2, and this 4 is adding to the function, so that tells me I'm going to move up 4. You got it. Now, some of these points are going to go off grid, but you can use a little bit of estimation to figure out about where this is. So I've got 4 nice points to try to follow. So I'm going to take this one and go left 2, up 4. And I've got one of the points on my final graph. Then let's take this point, move it left 2, up 4. I've got another final point. This one, I'll move it left 2, kind of goes off grid a little, up 4. And this one definitely goes a good amount off grid. But if you want to, you can always just kind of move it anyway. Left 2, up 4, 1, about 2, 3, 4. But very importantly, you need to move the asymptotes. The asymptotes only stop being the x-axis and the y-axis due to the movement. So if I move this plus sign left 2 and up 4, I can see where the center of my 2 asymptotes meet, and I can now draw those asymptotes. And I'm drawing dashed lines for asymptotes. And from there, I'm going to take these 2 points. Let me highlight them. And I know that they connect together because they are following this green. This graph here is being moved to create this one. And then we also got these 2 points from the moved graph. Now, I've found that some people prefer when I give them extra grids, because we're reaching the point where I don't want to just tell you, here, graph the parent graph. Here, now graph what you get when you multiply, and then here's another grid, now graph that multiplication of the parent graph moved. I want you to know from just looking at a function's equation the steps you need to take. Who is the parent graph? What is the multiplication? And then what is the addition, subtraction movement? But also I found that some people really like it if I put more grids on for you to draw your own slow motion up to the main thing so that you don't have a mess that looks like this. And so I will, with a test, I will put more grids in than you necessarily need for your own purposes, that you don't have to use all of them. Okay, so let me show you what I have in the answer. And I apologize to the colorblind. The 1 over x graph is the only one that's in an assortment of a like quadrant 1 to quadrant 3. Then I'm going to highlight right now the multiplication graph. The y equals negative 9x. And then can you see from there the final graph that is moved? And I also have the final graph separately drawn, where I have it in that same frame that I gave you for a grid. So that is basically what you're going to be doing in your homework today. Let me just show you. We're going to go back to classwork because there's a little bit more that I want to do with you. But let me show you that you're going to do 3 of those on your own. And then I have an extra addition division problem because every day I'm going to have you just practice that algebra again. Today's quiz, the addition multiplication I kept on the easier side, and I want to build you up to where you're confident when you get to the test to be able to handle problems that are a little bit more challenging but not crazy over the top. Now, going back to the classwork, I have some other fun things to show you that I don't expect you yet to graph on your own with homework. So here's number 3. I want you to do the division of number 3 and see what you get with that. So prepping the division, you have what you're dividing by. Ooh, very good. You are correct. As I start the division, the x squared is in the upper left corner. I need to figure out what to multiply x by to get x squared. Then I multiply the 2 and the x. Then I have to figure out what do I add to 2x to get 5x. And then I go for another round. What do I multiply x by to get 3x? Multiply the 3 and the 2. And then what do I need to add to 6 to get, 6. Hey, look at that. No remainder. So the answer to this division is literally x plus 3, but there is one issue. This is not going to be just the line x plus 3 because what is the domain of this function? Are there any numbers that I can plug into x and it goes, no, not going to happen? What?
0.
The number will make 0 in what location?
-2.
You got it. The domain is everything that does not make the denominator 0. So my domain is negative infinity to -2. So -2 is simply not allowed to go in. So what I'm going to write is, for the answer, I get x plus 3 out, but I need to keep in mind that x is not allowed to be -2 because the original problem has a divided by 0 there. And I just want you to see this, but I'm not going to be pushing you to graph this without guidance.
How did you find out that -2 didn't work?
That's going back to the original equation and looking at its domain. And when I look for its domain, I'm checking for, is there anything that causes its denominator to equal 0? And so those are numbers that are automatically kicked out of the domain. Even if I can simplify it to something nice, that -2 is still a problem. It's not allowed to go into the domain. And what you actually want to realize happens is every single number besides -2 that I plug into this numerator and this denominator will give me the same answer as if I just plugged it into x plus 3. It'd be so much easier to just plug it into x plus 3. So no matter what number I plug into x in this fraction, I will get the same result as x plus 3 would give me, with the exception of I'm not allowed to put -2 in. So as a graph, you have a line with a hole in it. What I'm going to do is I'm going to start by drawing the entire graph of the line y equals x plus 3. So I've got y-intercept 3 and a slope of 1. And for the sake of it, I can draw a line. Yay! Because otherwise this would not be as nice. Okay, from there, come on. There we go. However, how do you draw a hole or a missing point in the graph? Not easily. We have symbols for it because you really can't draw a point that's missing. So what you want to do is locate x equals -2, and where the graph is, you actually put a circle, and that circle is supposed to be not filled in. I can tell the difference between when you have a circle filled in like this. See how this, I can see it's filled in, whereas this, I can see that it's meant to be a missing spot in the graph. And the graph that I have in the answers, I was able to draw that hole in. But I don't expect you to easily just be able to, it's not going to look fantastic. You just want to know that this particular rational function is actually just a line with one point in its domain missing. There's a wide variety of graphs I can get with rational functions. Only some of them I'm going to ask you to graph on your own. And so far, the only ones I'm having you graph on your own involve the parent graph 1 over x. The graph for number... The graph on number 4, you will not in this class be graphing on your own. I'm specifically telling you that I want you to use technology to see the graph. But the first thing I want you to do is do the division. So let's do the division together. We're dividing by x minus 1. We start with 2x to the third power. And then what do we multiply x by to get 2x cubed? Multiply that 2x squared by the -1. And then what do I add to that to get -7x squared? Then what do I multiply x by to get -5x squared? Then multiply the -5x with the -1. And then you have to figure out what do I add to 5x to get, 0x. So what do I need to add to 5x to get 0x? You got it. Now, I'm almost there. What do I need to multiply x by to get -5x? Multiply the -5 by -1. and I needed some more boxes, but you can always add more boxes on, just like if I don't give you a big enough grid, make it go a little farther. What do I add to 5 to get 6? 1. The result of this division is 2x squared minus 5x minus 5 plus a remainder of 1 that didn't get divided by x minus 1. Now, I have in the answers the graph that you get with your technology, but I want to show you a little bit more than that on top of it. So I've got that graph ready. Oh, Desmos is reminding us all to vote. Do you see up there? All of you at least will get to vote in the next presidential election. I thought imaginary numbers and sine waves are dead. Oh, okay. This may look a little bit crazy. And actually, I realize that I want to switch where I'm presenting, which also is going to affect the screencastify. So trying to think, because I've got a bigger screen that I can show you more on, because this smaller screen that I have won't allow me to make it where I want you to see it. Okay, I'm going to deal with this because it'll be too much to mess around with this. I have another function waiting. Can everyone see which function I have right here? Actually, I forgot to put y equals. Do you recognize who this is? This polynomial right here. If you look back at the problem we just did, how is it related to the problem?
Is it the quotient?
Yes. And I want you to see something because this is very fascinating. Are you ready? Brace yourselves. Were you expecting that to be quite so similar? Look at that. If I go back and forth between them, look at how similar it is in some places and how different it is when I get too close to what makes that denominator 0. Now, if I'm graphing the rational function that's in red here, there is a vertical asymptote of x equals 1. And I'm going to put that down as a dashed line. And I'm going to take this out of the mix. And you can see that there is a vertical asymptote that it follows. I want to repeat myself that you will not have to draw this on your own in this class. This is just allowing you to see the possibilities and also tell you how much information that quotient actually gives you. That quotient is going to tell you about some of what the graph looks like. The remainder holds the graph back from being able to be this parabola. But otherwise, if it weren't for that remainder, you would be able to create this parabola graph with a hole in it. But that remainder causes it so that when you're near what makes that denominator 0, the graph just has to fly off to infinities. But when you are at the far right or left end, it is forced to be more and more like that quadratic graph. Isn't that interesting? So again, you are not going to have to graph these on your own. All I want you to do in your classwork is sketch a little bit of what you just saw, and the answer should look somewhat like, there's a screenshot of the graph. So try to make it look a bit like that. Notice that vertical asymptote. And that's all I wanted to go over with you today. And just allow you to see how division can help you know a little bit more about your rational function. All right. A reminder, I'm going to give you the quiz on addition and multiplication. And know that I've got for each of them a place where you can show your work and you can type the answer. You don't need to say y equals or anything, just the answer. So like if you were given problem number 1, you would literally just say the number 2. If this was your answer, you can write it in this way with the math version. If you are confused about how to write it, you can type it with parentheses and I'll know what you mean. So you've got a good amount of time to work on it. I have 3 problems, and I think some of you will finish early, but I want to give you a good amount of time. Do you feel like you understand the steps that you need to take? And by the way, I can't stop you from having notes in front of you, so why not have notes in front of you? I allow notes. You can use your homework and your classwork as a guide. I just realized I'm